Okay.
We're good?
Yeah. I don't even know if this is on. Wait, how do I check if it's on, bro?
It's,
You want to
there's a
record
little
them?
there's a little red. Nah, it's recorded. It's recorded.
Oh, it's recording.
There's
All right.
like a
You want
little
me to
red
start?
button thing.
Okay.
All right, we just made it like a minute longer, bro. We
All
good.
right. That's good. Hi, Mr. Farley. Hi, class. This is Billy. And
And
what's your name? I
Sasquatch.
forgot your name. Yeah, Sasquatch.
Sasquatch.
Yeah.
Right, yeah.
Okay. So our topic was magnetics. All right. And I think we did this question in class before. I'm pretty sure. So I'm just get right into it. This is 2019's number one, A and B. It's to do with magnetic and electric field. All right, so I'm gonna start off. The figure above shows a particle with positive charge plus Q traveling with a constant speed v initial to the right and in the plane of the page. The particle is approaching a region shown by the dash box that contains a constant uniform field. The effects of gravity are negligible. Okay. Part A, question 1. On the figure below, draw a possible path of the particle in the region if the region contains only an electric field directed towards the bottom of the page. Okay, so if there's an electric field going down at the bottom of the page and the proton, yeah, the particle, not proton, it's the particle going this way, it'll be going like that, pretty much. Okay. And 2, on the figure below, draw a possible
Is that the
path
one
of
I'm
the
doing?
particle.
Oh
You
wait,
want to do
no,
2?
no, no, no,
Oh,
no, no.
alright. Okay. On the figure below, draw a possible path of the particle in region if the region contains only a magnetic field directed out of the page. Okay, so the magnetic field is coming out of the page, therefore the particle would stop earlier on compared to 1 to 4, where electric field is going down, right? So instead of going that far near like the fourth, it would probably stop off by like the half mark here. So it would be like this. Okay. So for which of the previous situations is the motion more similar to that of a projectile and only a gravitational field near Earth's surface, and why? Okay, so all right. So do you know how the electric field one, this this particle stops off more towards the end, but once the magnetic field is pointing out of the page, it starts off near the half. That's how you know is that the motion in the electric field will be more similar to the projectile because the force or acceleration is always down or constant. Like it's in the shape of like a parabola. And the closest one would be electric field. That's also pointing down. Right. So it would be electric field. All right, I'm gonna draw that. Okay. Okay. Let me erase this a little. Okay. Okay. You can go with these.
All right, so in this one is another region of space contains an electric field directed toward the top of the page and a magnetic field directed out of the page. Both fields are consistent and uniform. A horizontal beam of protons with a variety of speeds enters the region, as shown above. Protons exit the region at a variety of locations, including points 1 and 2 shown in the figure. In a coherent paragraph length response, explain why some protons exit the region at point 1, others exit at point 2. Use physics principles to explain your reasoning. All right, so the magnetic and electric fields, they're gonna affect the protons in different ways. They're gonna go against each other. So one important factor that determines where the proton leaves is its speed, because magnetic force is affected by speed, or the effect of magnetic force on the proton is affected by speed, while the electric force is not. So since the forces have like a net zero effect, right? There's like a certain speed where they're gonna deflect higher, like higher to the page versus lower to the page, because the magnetic force is gonna like overcome the electrical force. And yeah.
I agree. Thank
So yeah,
you.
so slower protons would exit higher than faster protons. And yeah.
I agree. Thank you, Matthias. If you guys
I
have any other questions, you can always email us. We're always
yeah.
here. And yeah, I think that ends our question. All right. Thank you, guys.
We done?
Oh,